Hello friends, how are you? Welcome to my channel Hallabool Physics. With the blessing of the God, I hope that you all are okay. Take care of you and your parents and stay at home. Okay, today's topic now, gas thermometer. Okay, gas thermometer now. What is the principle of a gas thermometer? Yes, gas thermometer is based on the principle of change in volume or change in pressure. Change in volume or change in pressure for a given mass of a gas. Yes, it is based on the principle of change in volume. Change in volume means pressure constant or change in pressure means volume constant. Now, when pressure constant, that thermometer is known as constant pressure gas thermometer, and when volume constant, that thermometer is known as constant volume gas thermometer. So basically there are two type of gas thermometers. One is constant pressure gas thermometer, another is constant volume gas thermometer. Now if pressure is constant, what constant? Pressure is constant, volume will be changes, and if volume is equal to constant, yes, pressure will be changes. So here pressure constant, volume changes. Here volume constant, pressure changes. So this thermometer is based on the principle of change in volume. Change in volume means pressure constant or change in pressure means volume constant. Now if pressure is constant, volume changes. So T is equal to Vt minus V naught divided by V100 minus V naught into 100. So T is equal to Vt minus V naught by V100 minus V naught into 100. Pressure constant, volume changes. Volume constant, pressure changes. So T is equal to, it is Pt minus P naught by of P100 minus P naught into 100. So there are two relations we have taken in our class now here. One for pressure constant, another for volume constant. Now question is arising here, where we can apply this relation. Where we can apply this relation and where we can apply this relation. Yes, it must be clear here. Yes, this is the valid relation when pressure constant is the valid relation when volume constant. This relation we can apply for constant pressure gas thermometer. This relation we can apply for constant volume gas thermometer. So there are two type of a gas thermometers. One is constant pressure gas thermometer, another constant volume gas thermometer. This relation we can apply when pressure constant. This relation we can apply when volume constant. These all are the volume of a gas. These all are the volume of a gas at 0 degree Celsius, at 100 degree Celsius, and at unknown temperature T degree Celsius. These all are the pressure of a gas at 0 degree Celsius, at 100 degree Celsius, and it is at T degree Celsius. T is the unknown temperature. Here also T is the unknown temperature. So both are the valid relation for a gas thermometer. Now what is the temperature range of a gas thermometer? Yes, temperature range minus 200 degrees Celsius to 500 degrees Celsius is the temperature range of hydrogen gas thermometer. What is the temperature range of hydrogen gas thermometer from minus 200 to 500 degrees Celsius? Minus 268 degrees Celsius to 500 degrees Celsius is the temperature range of helium gas thermometer. What is the temperature range of helium gas thermometer? From minus 268 degrees Celsius to 500 degrees Celsius. And the last, minus 200 degrees Celsius to 1500 degrees Celsius is the temperature range of nitrogen gas thermometer. So these are three gas thermometers. Is the temperature range of hydrogen gas thermometer. This is the temperature range of helium gas thermometer. Is the temperature range of nitrogen gas thermometer. Now, questions arising here now. Hydrogen cannot measure the temperature above 500 degrees Celsius. So why hydrogen cannot measure the temperature above 500 degrees Celsius? Reason simple. Hydrogen has a single bond. Hydrogen has a single bond. If temperature is slightly more than 500, if temperature is slightly more than 500, hydrogen bond will break. Hydrogen bond will break. All energy will be used in breaking the bond. All energy will be used in breaking the bond. It means energy will not be used in the expansion. Energy will not be used in the expansion. So hydrogen cannot measure the temperature above 500 degrees Celsius, because above 500 degrees Celsius hydrogen start to diffused. Hydrogen starts to diffused. Now next question. Hydrogen and nitrogen both cannot measure the temperature below minus 200 degrees Celsius. So why hydrogen and nitrogen cannot measure the temperature below minus 200 degree Celsius? Simple reason behind it here. Below minus 200 degrees Celsius, hydrogen and nitrogen both start to liquefied. Both start to liquefied. What does it mean by this here? If both start to liquefied, will not be as a gas thermometer. Will not be as a gas thermometer, converting into liquid thermometer. Converting into liquid thermometer. So hydrogen and nitrogen both cannot measure the temperature below minus 200 degree Celsius, because below minus 200 degrees Celsius hydrogen and nitrogen both start to liquefied. Now question is arising here, why we use hydrogen gas? Why we use hydrogen gas in a gas thermometer? Simple here. Hydrogen is lighter than all other gases. Hydrogen is lighter than all other gases. Yes, if hydrogen is lighter than all other gases here, it will have a lower density. It will have a lower density. Lower the density, greater will be the expansion. Lower the density, greater will be the expansion after rise in temperature. And greater the expansion, better will be the accuracy. Greater the expansion, better will be the accuracy. So we use hydrogen in a gas thermometer for the better accuracy. For the better accuracy. Now the question is arising here. Which gas will be used to measure very low temperature? Which gas will be used to measure very low temperature? Yes, it is helium gas. Helium is used to measure very low temperature. It is up to minus 268 degrees Celsius, which is very low temperature. So which gas is used to measure very low temperature? Yes, it is helium gas. Which gas is used to measure very high temperature? Yes, it is nitrogen. It is a nitrogen gas. So nitrogen gas is used to measure very high temperature. Helium gas is used to measure very low temperature. For the better accuracy, we are using hydrogen gas. We are using hydrogen gas. Now we can take one important question now here. For the better accuracy, a gas should be filled at low pressure and low temperature, high pressure and high temperature, low pressure and high temperature, high pressure and low temperature. Now question here, for the better accuracy, yes, greater the expansion, better will be the accuracy. Greater the expansion, better will be the accuracy. So greater the expansion possible only whenever gas is filled at low pressure and high temperature. Low pressure and high temperature. You know, low pressure means more will be the expansion. Low pressure means more will be the expansion, and high temperature means again more will be the expansion. More will be the expansion. Greater the expansion, better the accuracy. So for better accuracy, a gas should be filled at low pressure and high temperature. Okay, now few numericals. One numericals we have taken on the board now. The reading of a gas thermometer at 0 degrees Celsius and 100 degrees Celsius are 50 centimeter and 75 centimeter of mercury column respectively. Then the temperature at which its reading is 80 centimeter of mercury column. Okay, first question is arising here. Yes, what we are using here is a gas thermometer or liquid thermometer. No doubt here clearly mentioned is a gas thermometer. Which thermometer? Gas thermometer. Now gas thermometer is based on the principle of change in volume or change in pressure. For a given mass of a gas, there are two types of a gas thermometers are possible. One is constant pressure gas thermometer, another constant volume gas thermometer. So first must be clear here, is it a constant pressure gas thermometer or constant volume gas thermometer? It will be clear. Okay, it will be clear from here. Yes, here height of mercury column changes. Height of mercury column changes. Here pressure is given in terms of the height of mercury column. Pressure is given in terms of the height of mercury column. So temperature changes, height of a mercury column changes, means pressure changes. And if pressure changes, volume will be constant. Volume will be constant. So this question is based on constant volume gas thermometer. Constant volume gas thermometer. So if volume is constant, then we can apply the relation T is equal to Pt minus P naught by P 100 minus P naught into 100. This will be the required relation to solve our question. P naught is the pressure of a gas at 0 degrees Celsius, pressure of a gas at 100 degrees Celsius, pressure of a gas at unknown temperature. But there is a problem here. Here it is pressure we are using, here we are using height of mercury column. No doubt here. There should not be any doubt in this part here. Pressure is not only in terms of atmosphere. Pressure is not only in terms of Newton per meter square. Pressure may also be in terms of the height of mercury column. So how to convert this relation into a required relation? Into a required relation. You know all students here, pressure is equal to H rho into G. Pressure is equal to H rho into G. H is the height of mercury column, rho is the density of mercury, and G is the acceleration due to gravity. Keeping density and gravity constant. Keeping density and gravity constant, we can apply this relation here. T is equal to Pt means it is Ht rho into G minus P naught is equal to H naught into rho into G divided by pressure at 100 degrees Celsius is H 100 rho into G minus P naught is H naught. P naught is H naught rho into G into 100. I repeat again here, keeping density of mercury constant, gravity is already a constant value. So rho G will be cancelled. And if rho G cancel, one important relation will now become here. T is equal to Ht minus H naught by H 100 minus H naught into 100. So this will be the required relation to solve the question. Yes, height at 0 degrees Celsius. Height of mercury column at 0 degrees Celsius. You know here at 0 degrees Celsius, height of mercury column is 50 centimeter. And height of a mercury column at 100 degrees Celsius is 75 centimeter of mercury column. Then the temperature at which its reading is 80 centimeter of mercury column. So this is nothing but as H naught. H naught. This is nothing but as H 100. H 100 and this is Ht. This is Ht. Yes, height is at unknown temperature. Height is at unknown temperature. So T is a required part now. What is Ht is equal to 80 minus H naught is equal to 50 by H 100 is equal to, what is H 100 is equal to 75 minus H naught is equal to 50 into 100. Now solve this relation. You will get the unknown temperature 120 degrees Celsius. That was the required part here. Check your options. Yes, it is answer D, 120 degree Celsius. Okay, one more question. The upper and lower fixed point of a thermometer are separated by 160 millimeter of mercury column. Then the temperature at which its length will be 40 millimeter above the lower temperature. Okay, how to solve the question? Okay, one diagram I want to take it now is a diagram of a thermometer. Any thermometer may have two fixed points. One is lower fixed point, another is upper fixed point. Now lower fixed point is 0 degrees Celsius on centigrade scale. Upper fixed point is 100 degrees Celsius on centigrade scale. Unknown temperature will lie in between lower fixed point and upper fixed point. So this is the unknown temperature lie in between lower fixed point and upper fixed point. Now is a length at 100 degrees Celsius. Length of mercury column at 100 degree Celsius is the length of mercury column at 0 degrees Celsius. Now both are separated by 160 millimeter. So this length is equal to given 160 millimeter. So what is given part here? Upper fixed point and lower fixed point are separated by 160 millimeter. It means L100 minus L0 is equal to given 160 millimeter. 160 millimeter. Then the temperature at which? Its length will be 40 millimeter. Its length will be 40 millimeter above the lower temperature. So above the lower temperature, this length is equal to given 40 millimeter. So we have required the temperature when the length is 40 millimeter above the lower temperature. So that temperature is required. Here length will be LT. Is the length at unknown temperature. So LT minus L0. Is equal to given 40 millimeter. So LT minus L0 is equal to 40 millimeter. Both are given but not directly, indirectly given. Not directly given, it is indirectly given. So upper and lower fixed point are separated by 160 millimeter and LT minus L0 is equal to 40 millimeter. We have required the unknown temperature T degree Celsius. Now question is arising here, which thermometer we are using now here? Is it a gas thermometer or liquid thermometer? Yes, there should not be any doubt here. Here clearly mention mercury. What mention? Mercury. Mercury means we are using a liquid thermometer, and liquid thermometer is based on the principle of change in volume with rise in temperature. So volume changes, pressure does not change here. Volume changes, pressure does not change. So T is equal to, now question is arising here, a question is related to the gas thermometer or liquid thermometer. Yes, it should be clear here we are using mercury. What we are using? Mercury. It means we are using or we are discussing liquid thermometer, not gas thermometer. And now liquid thermometer. Okay, now question is arising here. Yes, this is the question related to the gas thermometer or liquid thermometer. Yes, it is clear from here now. What mention it is? Mercury. Mercury means this is a liquid thermometer. It is not gas thermometer. And liquid thermometer is based on the principle of change in volume with rise in temperature. So unknown temperature we can find out by the relation of Vt minus V0 by V100 minus V0 into 100. So this is the unknown temperature relation. T is equal to Vt minus V0 by V100 minus V0 into 100. Yes, V0 is the volume of a liquid at 0 degrees Celsius, volume of a liquid at 100 degrees Celsius, volume of a liquid at unknown temperature T degree Celsius. Now there is a problem here. A relation is coming in terms of the volume. We know the relation in terms of the volume, but data are given in terms of the length. So what we can do it here? How to solve our question? By one concept now. Okay, see all students now here. Yes, is a thermometer. When temperature increases, length also increases. Temperature increases, length also increases. Area of cross section of any thermometer does not change. So temperature changes, length changes, but area of cross section remains constant. So we can apply this concept now here. Yes, you know it here, volume is equal to area into length. Volume is equal to area into length. Keeping area of cross section is constant. Now this part we can apply here. This relation we can apply here. T will become equal to, in place of Vt we can use A into Lt minus V naught is equal to A into L naught divided by V100 is A into L100 minus A into L naught into 100. So area of cross section of any thermometer does not change. Temperature changes, length of mercury column also changes. So this will be cancelled. Area of cross section will be cancelled. One new relation will now become here. What is new relation? T is equal to, yes, LT minus L naught divided by L100 minus L naught into 100. This will be the required relation to solve our question. Okay, by this relation we can solve our question. Yes, LT minus L naught, LT minus L naught, LT minus L naught is 40 millimeter. So this value is equal to 40 millimeter. So T is equal to 40 divided by E. What is L100 minus L naught is also given. L100 minus L naught is 160 into 100. Now after solving this relation you will get the value of T. T will come 25 degree Celsius. So T is the unknown temperature is coming 25 degree Celsius. But after seeing options here, yes, there is a problem here. Options are not given in degree Celsius. Options are given in degree Fahrenheit. But we are getting our answer into degree Celsius. Yes, it is simple to converting Celsius into Fahrenheit with the help of the relation we discussed in a class here. C is equal to 5 by 9 of F minus 32. That relation will now be helpful to convert centigrade into Fahrenheit. Centigrade into Fahrenheit. So T is equal to 25 is equal to 5 by 9 of F minus 32. After solving this relation, you will get the value of F, and this F will come 77 degree Fahrenheit. Now our answer is matching with the option number D. So right answer is D, 77 degree Fahrenheit.